Ooh, that was a fail. Hello, I'm that James guy, and today we're going to continue assembly on my 1 liter turbocharged 3-cylinder Ford engine from my Ford Fiesta that I bought for $900 because it had a hole through the side of the block. Yeah, we've already kind of put the bottom end together, and we're just going to continue on, just kind of in order. So next to the cylinder head, and we'll go on from there. Just using a little bit of Scotch-Brite on the cylinder head deck. It doesn't have to be super shiny or nothing, just kind of clean so that the gasket can adhere to the cylinder head. Not much more than that. Alright, I'm going to clean the deck with the engine on its side just so that stuff doesn't fall into the cylinders and get all over stuff. I'm going to do the old gasket scraper and the old Scotch-Brite move here, and I'll get it all cleaned up and then you can chuck the head on. You're going to also want to make sure that you always clean out the head bolt holes real good. You don't want any debris caught in those things, so what you do is you kind of blow those out with brake clean. That's all I use. Okay, I always like to put a little bit of oil in the cylinders before I put it together, so I don't know why. I just always do. And then we'll give this in one final wipe down. Good to go. Here we have one of these crazy multi-layer metal magic crazy gaskets that everyone likes to use nowadays. I don't know how they seal, but they seal for the most part. Let's just line this thing up right there. And then our cylinder head. Hey, that seems on. Okay, we got all new head bolts here. There's quite the torquing sequence. It does not say in the manual to lubricate these bolts and threads before doing this, so I'm not going to. Probably don't need to, hoping. You're supposed to torque them down, or you're supposed to tighten them down until they're finger tight. If you saw the disassembly, I don't actually have, this is a TP50 socket. You can see that there, it's not just a normal Torx, it's got like wider ends, they're not pointy, but anyway. First stage is 89 inch-pounds. Next is 40 Newton meters. So the spec is 10 Newton meters, then 40 Newton meters, then loosen them all 45 degrees, then torque them to 30 Newton meters, and then 90 degrees more. And then another 90 degrees. So really it's 180 on top of your final torque. Okay, now that that ordeal is over, next to put on the buckets, you could call them, tappets. You know, the camshaft acts directly on here and pushes the valves down. Now, there is different buckets. I'm going to try and focus in on it. So you can see there's a number. It is 900 in this one. That means something. That's the thickness between that bit in there and the top. So when we check our valve lashes, this is going to come into play, because if we have any valve lashes that aren't right, we're going to have to go ahead and take the cam back off and change these to different ones. I do have the spare engine, the original engine, so that shouldn't be a problem, I don't think. Next is camshaft installation. So what you're supposed to do is put the cams on, torque them down, 2 turns at a time. You want to gradually suck the cam down because certain valves are going to want to push down. I better probably remove this from torquing the heads, hey? 10 Newton meters on both cams, and then we're going to check valve clearance. And there's one spec for intake, but there's a couple specs for exhaust, and it's based on camshaft part number, so we're gonna have to kind of check that out. So here's the thing, valve lash intake 8.3 thousandths of an inch to 11.8 thousandths of an inch. Exhaust, there's two options, CM5G FC camshaft or a CM5G FD camshaft. The first one is 12.2 thousandths of an inch to 14.5 thousandths of an inch, and the second one is 14.9 to 18.5 thousandths of an inch. Here's the problem, there's a little part number right here that kind of tells you what engine it is, and it is CM5GFE. I only have options for FC or FD, and they're drastically different. I've googled it, I literally have nothing. Okay, so what we're going to do here to check the lash is we're just going to go on any cam lobe that's facing away from the lifter, so we can do that one, and then we'll just turn the camshaft individually till they face away. And you don't have to roll the whole engine up. We don't even have a timing belt on it yet, but we'll just do this one, and then we'll rotate it and do the other ones. So first of all, let's get the 8th thou. Spec is like 8.3 to 11.8, so we just start off with an 8th thou, and it goes in no problem. So I can put that right in between the cam follower and the cam lobe. Hey, let's get a better view on that. That's way better. Okay, 8th thou. Here's where I'm putting it. Putting it right here between the cam follower, or the tappet, and the lobe. So that goes in real easy, and it does on the other side as well. Next, we'll pull out the 9. So we got quite a wide range here. The 9, if it goes in, that means it is the clearance is greater than the minimum spec. 9 goes in. A little bit of drag. 9 goes in that one. Next we'll do the 10. Ooh, I pushed pretty hard and that 10 does not go in. So we're in the 9s, somewhere in the 9s, which means we are in spec on that lobe. Until that'll be number 3's pointing up. So as these things wear, clearance will decrease because the valve will hammer in. It'll beat into the seat, but as we saw before, if you've been watching, the seats looked really good on this thing, so I don't think we have that issue. And that 10 will not go in, and that 10 will not go in, so it's exactly the same thing for this one. So the 8 goes in real nice, the 9 went in. Oh, 10 does go in. It's super tight there. It's going in, but it's a little tight. Okay, my feeler gauge sets have been mangled. I've stolen feeler gauges out of them over the years, but look. I found a 5, but look, I found a 5 and a 6. So together, I'm no calculus instructor, but that adds up to 11. So I'm just going to push that in there. Nope, won't go. So we know that one is somewhere between 10 and 11, well within spec. Now we can move to the exhaust. Okay, I've managed to wrangle up enough feeler gauges to do the exhaust cam here, and just playing around here, and it seems like these valve clearances are falling into that second category, the FD category. They're kind of real close to that spec, even though this isn't one of those. This is an FE. You can see the 16 goes in nice and tight, which would be right in the ballpark for one of those. I got a 7 and a 10 here to make my 17. And it does not go in, but it does go in here, but I don't think the 18 will. Nope, no go. If you had to go ahead and make an adjustment, let's say this guy was really tight, what you would have to do, or loose, let's say, what would you have to do? There's this big procedure. You pull the cam off, you pull that lifter off, and on the underside of that lifter, like I showed you earlier, there's that number, and that number means something, and you punch it into this little calculator and you put a different tappet in that is thinner or thicker to make up the difference. This is no different than motorcycles, the way you do a shim and bucket style on a motorcycle. Thankfully, we don't have to do that here. We can just kind of keep putting this together. My next thing is I'm going to have to get my timing tools from somewhere. I don't have any. Next we got to get these rear cam covers on, so these are going to bolt right there. There's one that bolts here where the vacuum pump bolts to. I just want to show you how the mechanical side of gasoline direct injection works. So you can see here we have a 3-sided lobe on this camshaft, and since it's a 3-cylinder, it's going to have 1 pulse per engine firing, and this little tappet sits right here. And as this thing turns, I'll just turn the camshaft here, and you can see what kind of happens here is this kind of goes up and down 3 times per revolution. And once we get this rear cover on where the high pressure pump bolts onto, you'll see kind of how that works. This high pressure fuel pump mount actually seals to the outside of the engine, so you have to use some RTV on this. You have to apply it kind of like here on the inside of the bolts and around here, down here, and through there. So we'll just put a small layer on there, we'll torque it up, and then we'll move on to the vacuum pump drive. Same thing. That one just has a little kind of an adapter, and it plugs into the back of the camshaft here, and it just drives a little vacuum pump back there. There's that cam lobe that drives this fuel pump. That's the bottom that the cam goes up against, and this is the top where the fuel pump gets activated against. So we just put a little bit of oil on here, a little bit of oil on the camshaft for good measure. It just goes, come on. There we go. You can see what the end of the fuel pump looks like. There's just a spring-loaded plunger. This thing just goes in and out on top of that cam follower, and it sucks in fuel here and pushes fuel out here. So from the high pressure pump, fuel just comes out into this line into the high pressure fuel rail. Gets to about 2000 psi roughly. And then you can see down there you got an injector, 1 injector, 2 injector, 3 injector directly into the combustion chamber. And that is the mechanical side of gasoline direct injection. This is what I need to time this mighty engine. Let's open this up. All of these fancy tools in here like camshaft holders and timing peg here, flywheel holder. Thank you to the nice people at West Coast Ford Lincoln in Maple Ridge, British Columbia. They lent me these tools to borrow. So let's attempt to get this thing all time. It looks like this hasn't even been used. That's the craziest thing. I think Ford just sends their dealers mandatory tooling to fix these engines. And then I'm thinking every engine problem they've ever had probably just got a new engine anyway. Here's our camshaft holding tools. Nope. Oh yeah, there we go. That lines up. Uses the valve cover hold down bolts to hold the camshafts in their correct position. So you tighten this down, I presume. And there's a square piece on the camshaft. This little kind of grippy thing kind of grips around as you tighten this. And you torque it all down. And that makes the camshaft timed in the correct position. So you hear that square bit? That gets gripped right here. Next, we have to put the timing pin, the timing stub, it's called timing peg in. First you gotta remove that. Oh, interesting. And then this goes in its place. So what you do is you wind this in, and then you rotate the engine clockwise until it stops. And what happens is something on the crankshaft is machined to butt up against that peg, and that's top dead center. I have a screwdriver down the injector hole on number 1, so we'll just see if it coincides with that timing peg. Hey, look at that. It does. So you notice it started slowing down. Screwdriver, as I go forward, I can feel that it's slowing down, and the crankshaft stops. And it is up against something. You can see what that timing peg is actually up against. It's up against that machine part on the crankshaft. Okay, next what you gotta do is you gotta take this part of the kit, which is the VCT, Variable Cam Timing Alignment Tool. And you just need to make sure the marks all line up. There's these tabs here that fit into the tabs on there, and this goes up. There's an EX for the exhaust camshaft, and there's an INT for the intake camshaft. These nuts holding the VCTs, the sprockets on, are loose. There is no keyway on anything, remember? So we gotta kind of put it into position in sort of the right direction. And once they are, you just kind of pull them off. So on the intake side, you can see how the line there on intake matches up with the eye. I guess that's just to make sure that the gear is perfectly lined up with the mechanism for the variable valve timing. And it seems to be. Same with the exhaust. It is lined up. Again, down here on this sprocket, for the timing chain, it's just loose on there. There's no keys. So you got to line this all up with that timing pin on the crankshaft. Okay, I have a new tensioner. This little tab fits in that hole. And there is a special tool that you're supposed to have in order to release this thing. This tool is a special tool, but it came with the timing belt tensioner, so that yeah, it holds it in the released position. And I cannot find a spec, and I'm going to give it 21 foot-pounds. All right, the infamous wet timing belt. Okay, that's not too bad. Just make sure things are still vertical. We're not like a tooth out between the camshafts. Not quite up and down, but that's pretty good. So then what we do is we just pull this out. We got a new seal. To remove that seal is really easy when it's not in the car. You just do that. Okay, this is the water pump, and this is where it passes through into the engine block through the front cover. Got to put a new seal on here. This came with the lower engine gasket kit, so we don't have to worry about that. Brand new. Just going to run some silicone here and bolt this thing up to the engine. Alright, this is all torqued up. I'll put the torque specs up on the screen because it was very complicated and convoluted and lots of steps. You know, next we have to bolt these VCT holders back up. They kind of use the same fasteners as the VCT actuators that bolt into these 3 bolts here. Now these bolts are oily, so this tool actually has been used before. So I was not telling the truth before. So our cams are locked. This thing has locked the gear to the actual shaft where it bolts on. And then it's positioned now with these bolts to this front cover. So everything here is timed. And now what we do is we tighten the nuts on the front of the camshafts so that this part to this, VCTs to the camshafts, will be timed to each other. So the initial torque, 30 Newton meters on these. Now we can pull these cam holders off. So what's supposed to happen now is 50 Newton meters, then 95 Newton meters, and then 45 degrees. That's a lot. And you hold the camshaft on the square part. And now 45 degrees. That's insane. This could be interesting. Torqued. Next, I'm going to get the oil pan all cleaned up and bolt it to the bottom of the engine. Just cover it all up so that dust and dirt can't get all over my new oil pump. Yep, we'll clean this up, bolt it up. Torque specs up on the screen, and we'll go from there. Well, before I put the pan on, I'd better change the rear main seal because the pan bolts to the bottom of it anyway. I can get it put on and all squared up, and it'll make it easier. I still have to put the flywheel on this thing after I get the pan on, so we can lock it through here, as you'll see, and we'll go from there. You want to check the surface of the crankshaft to make sure there's no groove in it by the old seal. It looks pretty good. Okay, now this goes on against there, and we just kind of go punk. See the little indent there, it fits perfectly into the block, so there's no concern whether the seal's rotated in the correct direction. It just is because of those indents. Torque is 10 Newton meters. How this works is, with the flywheel on, we're supposed to turn the engine clockwise. So we'll back it up a bit. I've got no spark plugs in, that's why no compression. And there it stops. And that's right here on this timing peg, which I still have in from before. And so that's the position that we need to lock the crankshaft in. You can see that is now bolted in there, but that tooth is locked in with flywheel. So no matter how hard we turn and torque up front, that should not move. Front crank seal time. New seal, here's the seal driver. Came in this kit that came with all the timing stuff, timing tooling. So all you do, this seal bottoms out on here to get the perfect depth. Okay, I'm going to put a little dab of oil on this new bolt, which comes with a captive washer. And I'll kind of make sure there's not too much oil. I don't want this thing flinging everywhere. Maybe a little bit on the threads, just to kind of make sure. And my front crank pulley is all cleaned up. It has to be timed as well. So I just stick that into the seal. I'm supposed to torque this up finger tight. Back it off a bit. There's a little hole there, and it lines up with a little hole in the aluminum right in there. So I would show you, but it's too late. You're supposed to use a 3/16 punch. Don't know if I have one, so I'm going to use a 3/16 drill bit. You can see the drill bit installed. A little bit of slop, but I guess that's good enough. We'll put it right in the middle. And I go 60 Newton meters, and then the craziness starts. 90 degrees, 5 times. So basically I'm going to put a paint pen mark here, and then it's going to be 1, 2, 3, 4, 5. So it's going to start aim this way, maybe it'll go on the flat there. It's going to end up being over here, but also plus a turn. This might get crazy. Okay. Oh, we're already starting to struggle. We're maybe halfway there. I got my helper here. Hold the engine down. Hey, that's better. Whoa. Okay, sorry. Try again.
Am I almost done?
Yes! The very last thing I'm going to do in this episode is get that valve cover cleaned up, new gasket, put it on the engine. You need to put a dab of silicone here, 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 and here, and here, and here. Any sharp transition or where a front cover meets the cylinder head. A little tiny dab of silicone, and let's get it on. Torque it to 10 Newton meters. Seems like anything in this size, 6mm thread, 8mm hex, seems to be 10 Newton meters moving forward. Like I've said before, this is the most satisfying part of this entire job. Well, maybe other than starting it and driving the car, but right here, putting the valve cover gasket in, it always wins as far as the most fun, satisfying part. Oh yeah. Okay, that's for sure enough for one video. I'm gonna pack it in there for now. Valve cover's on, so it looks like I've actually done something. Progress. It's all timed up. I can bring the tools back to Ford. Thank you, West Coast Ford Lincoln, for letting me borrow those. That is very good of you. Buy your car there, your next car. A couple things. Remember I talked about the camshaft, and the one that showed up in the manual was an FC or FD, and this is an FE, and it didn't make any sense to me. Well, okay, it turns out the reason was the donor engine Focus is an FE. I went and looked at the camshafts in the original engine, and they were FD. So many hours has gone by as I had to take it all apart all over again and pull the camshafts out and put the FD original Fiesta camshafts back in. And lucky enough, new camshafts in the not same head, the valve lashes were all still good. I checked them all over again, we're all good to go. Hey, follow me on Instagram, that__James__guy, as you can see up here. Hey, if this was useful to you, or just maybe even entertaining, hit the like button, please subscribe, and I will see you next time.